but given that you didn't have the background that I thought you had, I think this went over a lot of people's heads, okay? So that being said, we're going to be working with these rational exponents. Rational just means fraction, okay? And how it kind of translates into radical expressions. And before we put the radicals onto this at all, we have to review the three main exponent rules that you need to know. Okay? There are three, maybe four, there's four, but I'm going to review these three first. Critical exponent rules. One is when you're multiplying common bases. What do you do with the exponents? The other one is when you raise a power to a power. What do you do with the exponents? And the other one is when you're dividing a common base, in this case z. What do you do with the exponents? Okay? Now in Algebra 1, your exponents would have been all whole numbers. I get that. Okay? What happens in Algebra 2 is they become fractions. But in any case, what is the rule? When you have common bases, what are you supposed to do with the exponents? What? Add them. Good, good, good. Okay, so really up at the top, I'm just going to put, if you have a base of an x raised to the a power, and you multiply it by something that has a base of x raised to the b power, you can consolidate that into one term with a base of x and a new exponent of a plus b. Now, that can get annoying if your exponents are fractions, because although these both have a base of 7, I have to add these two exponents. Okay? And 1/4 plus 1/2 isn't as easy as 4 plus 2 would be. Okay? Because when you're adding fractions, you need a common denominator. And what would the common denominator here be? 4. We've got 1/4 plus 2/4, which is 3/4. So my new answer is 7 to the 3/4 power. And we're going to leave that alone for now. Okay? So you have to know this exponent rule of common bases. How about the second one? What's the rule when you raise a power to a power? Multiply. So we are going to need to take the 2/3 and we are going to have to multiply by 1/5. Now this isn't as bad. For once, multiplying is easier than adding, because you don't need a common denominator. When multiplying fractions, you just multiply across the top. 2 times 1 is 2. And you multiply across the bottom. 3 times 5 is 15. So this just ends up being x to the 2/15th power. Okay? So in symbolic form, that second most critical rule is that if you have a base raised to an a power, and then you also take that whole thing and raise it to the b power, that is the same as x to the a times b power. So you can get rid of those parentheses. Okay? Because parentheses should not be in your final answer, nor should common bases. And then in 3, we have a common base of z, but we are dividing. So what's the rule on the exponents? Subtract. So I have to do 4 minus 1/3. Subtraction of fractions is back to being as annoying as adding, because we need a common denominator. What's the denominator on the 4? 1. So what will be the common denominator? 3. So this one needs times 3 times 3. That's going to make 12/3 minus 1/3. And 12/3 minus 1/3 is how many thirds? 11/3. So z becomes 11/3. Okay? And so the third rule that I'll throw up in the top right is another common base rule. If I have x to the a, and I divide it by x to the b, I get x to the a minus b. Now, those radicals those exponent rules are a must, okay? Once all that simplifying is all said and done, then we may be asked to bring something to a radical expression, okay? But all the simplifying should be done in exponential terms, okay? You want to follow your exponent rules. The radical rule, if we have a variable raised to the numerator over denominator, that goes into radical form. How? If that's an n over a d for numerator over denominator. The denominator is correct, the root that you take. And then the numerator can either stay on as an exponent underneath the radical, or it can go outside. So it could be the x to the nth power could be underneath the radical, or keeping the d outside, so it's the d root of x, and then the whole thing can be raised to the nth power. That part where the n goes does not totally matter, okay? Depending on the multiple choice problem, it might be written differently in different problems. So if I want to take this one and go to a final answer, but keep the final answer in radical form, this 4 is the root, so it's the 4th root of 7 to the 3rd power. So it's the blank root of your base to the blank power. Okay? So how would I say this one, Anthony? How would I change this to radical form?
You do the radical.
So it's the blank root of, what are you filling in the blank with?
2 into that.
No, it's not the square root of.
Oh,
It's the 15th root of what? X squared. And this one here, Jake Phillips.
How would you say, like, the 3rd root?
Very good. The 3rd root of z to the 11th. Perfect. Perfect. Okay? But everything in this process along the way is done based on your exponent rules. We only go back to the radical form at the very end. Okay? So if I take this next one here, go ahead, take a minute, put down what you think that will become just based on the exponent rule first. Chance, what do you think? 64 to the 1/6 is correct, because this is your power to power, so we multiply 1/3 times 1/2, and 1/3 times 1/2 is 1/6. Molly, then what is this going to be now put into radical form?
I don't know how to say it, but 2 to the...
The blank root, what's the root?
The second root.
How? Alright, we're done with this.
Oh, the 6th
We've
root.
changed this to here.
Yes, I was looking at the wrong part.
That's okay.
6th root.
The 6th root of
64.
64. We don't even need to the first power. Now, is there any number that gets multiplied by itself 6 times to give you 64? Six multiplied by itself 6 times would be, okay, 2. 2 times 2 times 2 times 2 times 2 times 2 is 64. So actually the 6th root of 64 is just the whole number 2. Okay, if you ever want to see if this can be reduced, you can type in the 6th root of 64 if you want. Under your math key, so math is here, you can hit your math button, and you see it does the cubed root, but there's an X root there. Okay? You have to type in your 6 for the 6th root first. So I'm going to type in 6, and then math, and I would go down and I would select this. So I'm taking the 6th root of 64, and it will tell me 2. Okay? So that features under your math button if you ever are suspicious of being able to simplify. Like here, the 4th root of 7, can't really do anything with that. And then obviously if your base is a variable, you definitely can't do anything with that. Alright? Try 5 on your own. Simplify the exponent rule first, please. Okay, we add our exponents here. 1/5 plus 3/4, common denominator necessary. 4/20 plus 15/20 is 19/20. Okay, so in radical form, that's going to be the 20th root of b to the 19th power. Okie doke. Oh boy, we have a whole lot more on this. Let's jump to something like 17. Go to the back, go to 17. This one starts as a radical. The first thing you want to do is go to exponent rules. So this 4th root, I'm going to change the whole thing to being all of that to the 1/4 power. All of my work should be done in exponent rules. And then I'll go back to radicals at the end. Okay? But right here, this set of parentheses, m to the 4th has to be raised to the 1/4 power. That's a power to a power. So the rule there is to multiply. What's 4 times 1/4? 4 times 1/4 is 4/4, which is just 1, which you don't even really need. And n to the 8th to the 1/4, power to power is 8/4, and 8/4 is 2, so it would be n squared, and this would actually be done. There is no fractional exponent there, so I do not need to go to radical form. Okay? I'm giving you your homework now. I will also record myself just doing the rest of these if you feel like you need more guidance with them. Okay? And I will post the rest of this video as well. So it'll come in 2 parts. What we just finished in here, and then the rest of the examples I'll just kind of go through and talk out loud, so if you just want to watch them, you need to wrap your head around it, okay?